You said Pittsburgh said originally they were going to draft.
We took Claypool instead.
Yeah, that was smart.
He got the Antonio Brown disease. It would have been good. He would have been a good receiver if he hadn't got that AB disease. So, but it does happen. He just got the big head for no reason. So, whatever. All right, let's get started, please. So, so the first thing I want to do with you is hopefully you're looking at your unit circle. Hopefully. All right, and so I want to make sure that you understand kind of where the patterns occur in the unit circle because you're going to need that for kind of what we're talking. Oh my God. Why? Hold on. Let's try again. So, if I have a unit circle and you do not need to draw this. You may wish to really briefly sketch it on your paper. I'll leave that up to you. So, I just have a unit circle. We're starting, please. Thank you. All right.
Are you recording this?
Yeah.
Okay.
So, when we're talking about sine of theta, let's say equals 1/2. So where does sine of theta equal 1/2? What measure in, let's do degrees.
30.
30 degrees. Thank you. So that's going to be at 30 degrees and at 150. Okay. And so remember what we know about reference angles tells me that this is 30 and so is this. Right? So the pattern for sine is that your solutions are going to be symmetric across the y-axis, right? So if you're looking for another second angle that will give you a particular value for sine, at this point you should kind of understand that if you find this one, you should immediately go over here to find the other one. And if you're down here, you should immediately go over here because they are symmetric across that vertical axis, right? So what about where the cosine is 1/2 in degrees?
60.
So that would be 60 and 120, right?
No, 120 is negative.
So 120, so it should be
300.
right there. Good. So notice that the cosine solutions are symmetric across the horizontal axis, right? So if you find this first one up here, you should go directly down to find the other one. Whereas with sine, you'll go directly across. Does that make sense? So for sine, it's going to look like this. And for cosine, it's going to look like this, right? The locations, the general locations of whatever you're doing. All right, so now let's talk about the tangent. What pattern do the tangent values, let's say the tangent of 1, that's 1. So where does that occur in degrees?
45.
It's going to be 45, and then it's going to be directly across, right? If you're looking at your unit circle, these values occur in a straight line. So this is symmetric about the axis. So the pattern for tangent is going to be if you have a tangent value down here, it's going to be up there for your second. How far away are these two angle measurements? How far? 180 degrees every time. That pattern doesn't exist for sine and cosine, but it's very convenient, and you will see how convenient it is later that the two tangent angles are always going to be 180 degrees apart, right? These won't. they'll be at varying locations. But, the tangent values are nice, and you'll learn to really like those. So what is the objective of me telling you all this? Well, we are going to solve equations again. And I'm going to let you look at your unit circle at first, but you're going to do it without the unit circle, okay? So let's do example number 1. Let's do sine of theta equals negative square root of 3 over 2. So I want you to give me the solutions in degrees for now. We're going to move back to degrees for a minute. So if your calculators are in radians, please change them back by hitting the mode key. And then tell me, using your unit circle, what are the 2 places between 0 and 360 that have a sine ratio of negative root 3 over 2?
240, 300.
240 and 300. Okay, so this is what we found with the unit circle. So notice that 240 is about where? What quadrant?
3, 4, or 3.
And where is this one?
4.
So this one is be about 240, and this one is about 300. So notice they are following that symmetric pattern. And so now let's do this. Let's take the inverse. I want you to put this in your calculator.
Negative 60.
Negative 60 degrees. What angle measure that you found on your unit circle does that correspond to?
300.
300. Okay. So if you got this out of your calculator and I said I want theta to be between 0 and 360 degrees, how could you find that?
At 360.
I could find a coterminal, and then you would end up with 360. Now, how would we find the other one? Well, you need to draw the picture, right? So what I would do at this stage is I'd be like, all right, this is one of them. Why didn't I want this one? It's not within the range I requested, correct? Okay. Well, how can I find the other one? Well, I'm going to realize that sine is symmetric. And I'm going to know that the hidden solution that the calculator does not give me is here. And I know that this reference angle is going to be the same. What is the reference angle right here? 60. So what would the reference angle be for the second solution? So what would the second solution be? Right. So I would take 180, I would go 60 past that, and I would get 240, and then I would be able to get my second solution that the calculator did not give me. You're like, but Miss Apple, I can just look at my unit circle. I'm about to take you past the nice clean values on the unit circle. So we're going to establish some patterns that we can use and check on the unit circle, and then I'm going to take you to some angle measures and ratios that cannot be found on the unit circle, but they follow the same patterning as the pretty ones on the unit circle. Okay, so these are my 2 solutions for the range 0 to 360 degrees. This is what my calculator gave me. And the reason for that is because the arc sine function, if you remember inverse trig functions, the range of this function is negative 90 to 90, which is this. Right? When we talked about it last time, we talked about it in radians, when we talked about arc sine. We said its range was from negative pi over 2 to pi over 2. And this was when y'all were like, I don't like this. So let's go back to when we talked about this. So remember these?
Yes.
This is what we're using today. And recall that when we talked about this, the arc sine or inverse sine function had a range that was in quadrants 1 and 4. So what we just found is the calculator gave me this one, and I had to find this one that was hidden. Okay? So you can imagine, where do you think your calculator is going to spit out inverse cosines? In 1 and 2. And then you're going to have to find the hidden one in 3 and 4. Okay, so that's how we're moving back to what we kind of breezed over previously. So let's do another one that we can verify with our unit circle. Let's do a cosine now. Let's do cosine of theta equals -1/2. Let's find the values of theta with theta between 0 and 360 degrees that have a cosine ratio of -1/2 on the unit circle. You can give them to me in degrees when you find them.
240 and 120.
240 and 120. Let's take a look. Just did a brief sketch. 120 is going to be about right here, and then 240 is going to be about right here. Notice that patterning across the horizontal axis that cosine follows. So now let's go and actually use the inverse cosine function. So this would be theta equals cosine inverse, or arc cosine, of -1/2. Now tell me what your calculator gives you. Which you put it in there. Cosine inverse -1/2. 120. So exactly as we expected, by knowing the output of the arc cosine, it gave us one of the values in 1 or 2. So this one just happens to be in 2. You're going to have to find the hidden value in quadrant 3, because this is where I expect it to be. Well, if this is 120, what is the reference angle? The reference angle is 60. So how far past 180 do I need to go? There we go. 60 more. This will give me 240. That is the hidden quote unquote value for cosine that my calculator didn't give me. Notice we got the same answers. We just had to find this one because your calculator can only give you one.
So will it always end up with it being those two at the top?
Your calculator will only give you, if you use inverse cosine, your calculator is going to give you whichever value is in these two quadrants, and you're going to have to find the other one. Just like in sine, it's going to give you these two, and you're going to find wherever it is over here. Okay? So you just need to know, and I do it by drawing the picture, the little sketch. Because otherwise I get lost. Let's go again. Let's do a tangent one. Let's do a tangent one because the patterning is a little bit different. Let's do tangent of theta equals -1. And I want to know for what values of theta between 0 and 360 degrees. And we can use our unit circle for this one. So what two angle measures in degrees from your unit circle?
135 and 315.
Okay, let's visualize that. 135 is here. Is it?
Yes.
Yeah, my bad. And then this is the other one. So this one's 135. Remember, how far away did I tell you tangent was from its other solution?
180.
Ah. And you'll get 315. Get your little hidden one there. Okay? That's the cool thing about tangent. You can just add or subtract 180 and you'll get whichever one you're missing. You just got to make sure you don't move outside of the range. Tangent. If you prefer to visualize it this way, what's the reference angle from 135 to 145? So that would go down like this. Notice how it kind of follows a down down type thing. But the 180 trick always works, okay? Which makes sense because 180 is how many radians?
Pi.
Pi radians, which is the period of the tangent, right? So it's just going to be like, so. Okay, so now that we've seen this for values that are nice, let's look at some not nice values and let's remember. Let's see if we can remember sine, cosine, and the patterns for these. So let's go back and look again. So this is where we're going to be getting our values. And let's go back here. Okay. So sine is symmetric like this. Cosine is symmetric like this. And tangent is symmetric like that. Okay, so this is something that you need to memorize. Okay? You need to know this relationship.
I mean, as long as you know that A as B, C, you can have that, right? Because it's just where they're positive.
Not 10.
The pattern
Well,
follow.
10 just 180.
All students. Yeah, it's, I guess that works for sine and cosine, not for all students take. It doesn't work. It's backwards for, well, I guess, okay, let's make your pattern fit. I like that. I guess, well, it's not going to give it to you there. Never mind. If you want to draw it like that, you can. Then it's where it's positive. All students take it, I guess. Whatever. It's just know it's straight across for tangent. That works. Nobody's ever said that before. That's a nice way to memorize these however you can. Whatever. All right, let's try an equation that isn't so nice. Let's start with tangent. Now we are not going to have our lovely values to work with. So notice this is not any nice value that we've ever seen on the unit circle. So at this point, I'm going to take the inverse. And it's going to give me one of the two solutions. So this will be tangent inverse of 3.85. 75.44. Those are ugly. Okay, so to visualize it, where is 75.44? Well, it's about right here, right? So my other one's going to be over here.
Why can't you just add 75.44 to 180?
You can in this case, because these reference angles are equivalent. But you can also just add 180.
Yeah.
That's why that works, right? So yeah, yes, either way it works. But to keep it simple, we'll say, okay, 75.44 plus 180 is going to give me the second one, so that's 75. Plus 255. And I do, in general, like these to 2 decimal places. When they're gross like this. There we go. Let's go again. All right, let's do one that is sine. So let's do sine of, I personally prefer this way. To me, it's faster than looking it up on the diagram and having to memorize that. So now I'll just say, okay, well, theta is equal to sine inverse of this ratio. Sine inverse of 0.05. And I've got 2.87. So then I'm going to just make a brief sketch. So if this is 2.87 degrees, then I know that I need to just move back from 180 to 0.87 degrees. So 180.
187.
And that's your second value.
187.
I have
I'm
one, I'm at,
177.
yeah,
That's
177.
cool, man. I was just listening. I was just writing. No question. But everybody else paying attention. That's good. Congratulations that you were awake and you're doing this. Thank you for the collaborative effort. All right. Perfect. All right. Okay, cool. So let's go again. Questions so far? We love. I mean, eventually, like the equations, you'll need to go back to like factoring them and stuff. So, like, these are just trig equations, just like the other ones. Except now we use a calculator and you can't find them on the unit circle, but the process is exactly the same. All right, let's do a cosine one. Cosine theta equals 0.89. Theta equals cosine inverse of 0.89.
27.13.
27.13. And so then we'll make our little sketch. 27.13 is right here. And the cosine, remember your other one, your little hidden one should be down here. So if this is 27.13, I'm going to back off of 360 that far. 332.87. So that's your second solution for the cosine. All right. Well, look at there. Those are the simple ones.
I have a question.
Yeah.
Why, like, this is probably gonna end up something stupid, but why do you have to like take the inverse to begin with? Like, why didn't you just do like 360 or 0 plus 0.89? Like, why does it have to be in?
Because we're searching for the angle, and 0.89 is not the angle. That's the ratio of the sides with the triangle with that angle in it.
Okay, that makes sense.
So what this means, this 0.89, what this is it means since cosine is the adjacent over the hypotenuse, this means that the ratio of the lengths of the adjacent and the hypotenuse, the adjacent side is 0.89 of the length of the hypotenuse, or 89% of the length of the hypotenuse. So this is a ratio describing the relationship between the lengths of the sides. The inverse takes those side lengths and finds the angle that gives them in the triangle. Okay?
That makes sense. I just didn't know why we were.
No, that's a good question. Like one of the most pervasive misunderstandings in trigonometry is what's the difference between the ratio and the angle? And so that's a great question. Okay, let's do something that's gross. Let's do something that's gross. Oh yeah, let's do this one. And then we're gonna do. Let's do at least one more, and then. Oh, I mean, sure. Let's do one.
No, I'm
That's,
saying, are those
Please
considered
do
the
one
hard
that's
ones?
no. I mean, it basically
Oh,
is.
are we gonna have to do it where like we put it on the other side and then we do
We're okay. So, all right. So if you remember, we've seen some things like this recently, and you still are attempting to isolate the trig function with normal algebra. So if you are okay with the u substitution, I like to write my stuff in terms of u. So let u equal tangent of x. And so it's really just u squared plus u minus 12 equals 0. Can we factor this?
Yes.
So what are my two numbers? I'm multiplying to negative 12 and I'm adding to positive 1. So that's 3 and 4, and the 3 is negative, right? This is u minus 3. u plus 4 equals 0. So u is equal to 3 and u is equal to 4. Agree?
Yes.
And so now let's just say tangent of x is equal to 3. Tangent of x is equal to 4. Yeah, I just factored.
Well, what
Wait,
did
why
you
wouldn't
negative
the
for?
4 be negative?
Oh yeah, thanks. You're gonna catch me on stuff like that. The other way you could do it is you would just do, you would still do it the same way. You would just factor it with the tangent still in there. Do tangent x. Yeah, same thing. All right, so now what do? Well, we just say x is equal to tangent inverse of 3, and x is equal to tangent inverse of 4. This is no different than what we've been doing with the unit circle. And you expect two answers out of each of these. So tangent inverse.
Would it be negative 4?
I messed it up. I forgot to write it again. Yeah, negative 4. Thank you. Thank you very much. 3. This would be x is equal to 71.57. And, add 180 to it to get your next one.
So for these, we're gonna have like 4 answers.
Yes. Just like you did when you were doing it with the unit circle. You would expect 2 from each value. So tangent inverse of negative 4 is going to give me, okay, so here, this one's good. So look at this, negative 75.96. Is this in the range that I have been asking for?
No, so you gotta add
Yep, you gotta find a coterminal, so add 360 degrees to get the first solution. This is the first one. If you add 180 to this one, what's going to happen? It's going to go over. So what do you need to do instead? Back it up. Yep. Let's look. Let's see. We'll subtract 180.
104.04.
So look, visually what you're looking at is the calculator gave me this one, and I had to find this one, right? And in this one, the calculator gave me this one, and I had to find this one. You see how I did that? See how it gave me this one, and then I added 180 to get the second one, and here it gave me this one, and so I had to back up. It just depends. I mean, that's about as bad as it gets. It really doesn't get worse than that. Like I said, the only thing I've done is added a new way to get to your final answer, except you just can't use a unit circle. The rest is the same. So,
I think it's pretty easy.
you like it? All right. So, the rest of your day is going to be spent practicing.
Yes.
Can I use the restroom?
Yes.
I'm
done. I'm done.
But like, in the future, like next week's semester, my stomach is gonna be right now.
Yeah.
Huh? That's not nice.
All right. So, what I want you to do, listen up. I want you to do this one, and then I want you to bring it to me, and I'm going to give you your next one, okay? This one. Then bring it to me. And I'll give you your second one. Yeah. If you pay attention, I've already done several of these for you.
Stop. This off. No, but my question. No. I just have
Thanks, Sawyer.
No, just look, no, she was wrong. She was wrong. Yeah, I was like, I just like to look at it. I don't Oh, I was the teacher's like, yeah, she's like, oh, no, I just like it.
But here's why I would use this.
I was already
So you're like,
The way that I think about it is
Oh, I see what you mean. Like, it's not like it's redundant, but like it doesn't really have anything to say.
U squared, the other U squared is like X.
It's a shower.
yeah,
Does that make sense?
that's, yeah.
It's like, I want to make that second X. Yeah, I guess that would confuse people, it's like, what's the second R?
That's all, but if you understand it as a tool for whatever works. So there's only two of you. Okay. Where is this? 'Cause so that'd be 3. And the reference angle is 30, so over here it's a 180 plus 30. Yeah. Yeah. So, listen, I've been building this. Reference angles, unit circle, equations. And now this is like how I actually do this problem. So now but you have to learn the unit circle to be able to do this successfully.
So do you want 180 or do you want?
I want degrees. We're gonna be back in degrees for a minute, then we'll go back to radians. It's just with the numbers as nasty as they are.
0 and 180.
I just think it's a little more intuitive.